Hi, everybody. Let's look at Chapter 11 now, Goodness Fit and Contingency Tables. One thing I like about this chapter is that you've seen contingency tables before. Back in Chapter 4 when we were talking about probability. I don't know if you remember or if you're too traumatized from that chapter, and I'm making a joke because it's so hard. You know, Chapter 4 was very difficult, probably the most difficult of the whole class. Contingency or two-way tables, the tables that have rows and columns. We're going to be using that along with another type of problem called goodness of fit situation, along with a new distribution, and it's called chi-square. So we began inferential statistics in Chapter 7 when we were talking about confidence intervals. And then Chapter 8, we presented methods of testing claims about a single population. And then Chapter 10, we just finished considering correlation and regression and doing a hypothesis test there as well. Well, here now in Chapter 12, we're going to be doing two different kinds of hypothesis tests. One is called the goodness of fit test, where observed counts agree with some claimed distribution. And then the other one is called a contingency table or two-way frequency table. It's called, and it's section 12.2. And for both of these types of tests, we're going to be using something called the chi-square distribution. So it's pronounced chi like kite, not like chai tea. Okay, so it's chi-square distribution, and it has to do it's all about doing hypothesis testing for standard deviations or variances. Always those, no other types of population parameters. So you'll always see sigma or sigma squared in the hypotheses. Same hypotheses though. You'll still have a null hypothesis and alternative hypothesis. But these two types of tests, what the wording is, it's a little bit easier because the wording will always be the same for these two types of tests, not the same with each other. But if I'm doing a hypothesis test about the goodness of fit, then every goodness of fit test will be, the wording for the hypotheses will be very similar. It doesn't change as much as it did in Chapter 8, where we always had the null hypothesis contain the equal sign, and then we used a variable to be the mu is equal to 10 or a number. And then the the alternative hypothesis, mu was greater than 10, for example. It's not going to be quite like this here, and you might find it's a little bit easier because it's not so hard to come up with the null and alternative